right, everyone, we are live. Good morning. Thanks for joining us today for our DriveWorks webinar. This is an introductory webinar for all things DriveWorks, and really want to focus on how we can start thinking about saving engineering time for you today. So there'll be two of us leading the conversation, and it will be a bit of a conversation. Robbie and I will be chatting with each other about what a day in the life of working as a designer engineer is like, trials and tribulations of it all, what the tools are that we can use, and then finally, what can DriveWorks do to help the cause. So again, nice and short and sweet, half an hour. We'll zip through it. It's purely introductory. Love to follow up with you later if you have any questions or want to learn more about DriveWorks. So Robbie, you want to introduce yourself quickly?
Yeah, so guys, I'm Robbie Hoyler, Associate Director of Technical Solutions Manufacturing at TPM. As of last week, I've been with the company for 10 years, worked in industry, worked with robotics a ton, and yeah, just looking forward to giving you guys a great presentation today.
Yeah, and Robbie leads the entire team and department that is all things SolidWorks. He's been a SolidWorks user for a long time, oversees a lot of SolidWorks users. So really knows the ins and outs of SolidWorks, the good, the bad, the ugly. He knows it all. So we really help add that flavor to the conversation here. I'm Joel Hanneman. I am not as much of a SolidWorks expert, but I have been using DriveWorks for quite a while. Started when I worked in manufacturing myself. I introduced DriveWorks to a few manufacturing facilities of custom and configurable product. So I have lived the day in the life of installing DriveWorks, implementing it, putting it to use, and realizing all the benefits along the way. So I think we have both sides of the conversation pretty well covered. So let's get into it. As I said before in the intro, we got a pretty short agenda here. We're going to start off by just acknowledging what most engineers go through in their work life. What kind of tools do we have within the SolidWorks suite to get by all the better and kind of mitigate various things that aren't our favorite parts of the job. Then introduce DriveWorks, okay, as a proposed tool for doing things a little easier, a little better. And then talk about how DriveWorks can be transform itself from a tool into an enterprise-grade solution if that were desirable. Hi, Robbie.
All right. So really quick, we're just going to talk a little bit about some of the business level challenges that you guys are faced with. Now, there's a ton of things that consume engineering time. Usually when we look at customers and automation becomes a topic, the thing that we want to really focus on is the ETO or CTO, engineer to order, customized to order, configure to order, looking for designs that are, quote unquote, the same but different. And then we get into how do we define automation and configuration. So they are different. So let's talk a little bit about what is configurable and what we can actually automate. A lot of customers, I think the fear is when we say automation, it's the idea that, well, what I design is so complicated, there's no way to automate it. And we want to actually challenge that notion. So on this configurability spectrum, there's really two ends to it. There's things like widgets that are just not worth it to configure or automate. Those are things like, bolts. Like we have SolidWorks Toolbox. It's a list of configurable items. You don't necessarily need to automate that because it's super simple. So, the juice isn't worth the squeeze to automate something like that. Then there's the opposite end of the spectrum where it's truly one-off. It's, cell phone case, pair of scissors, diving board, 80-foot long sheet metal assembly. Doesn't matter. Those things don't relate to one another. So if you're truly making things that are one-off that have absolutely nothing to do with one another, that's obviously outside of the scope of what we would consider configurable. So let's go through a super quick example using this image, this configurability spectrum, to talk about what we mean when we say configurable, highly configure, etc. You take a catalog item. Let's say you make sheet metal tables. There's 6 or 7 different configurations that you sell a ton of. You pick that thing. It creates a BOM. It sends it to manufacturing. There's no work to be done. The design is done. It's set in stone. But When we get to lightly configurable, maybe you have those 6 or 7 items, but maybe you change the feet or you add a shelf to the bottom. That's what we would consider lightly configurable. And then you get to moderately configurable. Now we start to talk into the, okay, now we're stretching the length of the table. We start to add additional rules like, all right, once the table gets so long, you have to add legs. But everything before it that was lightly configurable, like the feet and the shelf and those options, those get added to it in complexity. Then we start getting into highly configurable. It's like, all right, any possible combination or existence or style of top or number of legs or number of shelves, that starts to get into a much more complex style of configurability. And we're adding many, 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 many variables to it and many different possibilities when it comes to dimension even. And then we get to the word custom, which is a dirty word for a lot of people. When we say custom, that means that there are so many design rules that go into that table that the only way to keep it straight, in fact, is to use an automation tool to characterize and take all of that tribal knowledge that you might have and apply it with the systems of rules and equations and predictability. In effect, if you can do it with a mouse and a keyboard, we can actually automate it.
That, Robbie, I think an interesting theme to kind of keep in mind is we're going to kind of talk about time-saving tools that mostly live in SolidWorks, and then that can work its way eventually to like a fully lights-out automated solution, right? Where there is no mouse, there is no keyboard, stuff just kind of happens in the cloud and it's all taken care of. And there's many steps in between, right? And every engineer, every engineering department, every company has a slightly different need, right? And so what's nice about DriveWorks is it can start pretty close to those time-saving tool-like solutions, right? We don't have to be concerned about, well, how do I automate the whole thing? Well, let's think about, well, it takes me 5 minutes to do a certain task 10 times a day. Well, DriveWorks could probably help you out with that, right? And so not everything has to be full bore, all the way, kind of maxed out solution. We really want to highlight that there are many steps to consider along the way. So.
Yep. There really is a crawl, walk, run approach to this.
Right.
So let's start talking about some of the tasks that you guys are faced with. I'm going to say a couple of examples. You guys are probably going to remember a time in your lives where this was true, but we all have these repetitive, non-value added, tedious activities that just come with the job, right? In engineering, I can't tell you how many times I found myself repeating the same thing. How many times do I have to enter the same part number into my ERP? How many times do I have to, make and recreate the same drawing 2 inches different for a flat? It's the same thing over and over and over again. So then we start to develop these shortcuts, like ways that we can do it faster. But a lot of times those shortcuts kind of introduce error into this. It's like, all right, so I create an automated tool. I start stretching the flat that I've used 35 times. But now, as I type in the number to change the flat, what if I, fat finger a number or something? Or if I do, somehow automate that and I start, manually putting that stuff into ERP, if anytime I am typing a bunch of numbers and, I've got 150 parts, I'm going to make little typos and errors. So what eventually happens when your organization gets large enough and you're trying to get, as much throughput as possible in an engineering environment, there's a ton of knowledge that kind of goes along with the correct way to do the job. And the idea of us just taking this lack of institutionalized knowledge where everybody kind of does things their own separate way to get the job done, we streamline that. We want to take that and make it consistent so that you're getting the same exact output without the errors, without the mistakes, time and time again. And honestly, that puts a lot of burden on the engineers to make sure that things leave consistently and leave and go to the shop floor accurately. And in a lot of companies, engineering is burdened with a lot more than even that. As part of the sales process, a lot of times when you go to quote a job, people kick that over to engineering to create these quotes or submittal drawings. And you're putting engineering time into this sales operation, but you haven't even won the job yet. So you're spending engineering time to get to a place where you can send it to the customer for them to say, yeah, I might not buy it after all. And so then you just washed all that time and effort down the drain.
And by the way,
So
like what are like typical win rates for manufacturers? I mean, if you're winning 15, 20% of the jobs you quote, you're in pretty good shape, right? So, I mean, what you just described, the vast majority of that time is, from a business standpoint, really pure waste.
yeah,
Right.
and
So,
that means that 80% of that time you spent did not result in a sale. So, I mean, if you get down to it, what is design, what is engineering? Well, we want to use our specialized knowledge to do value added tasks, engineering tasks. We don't want to be burdened with sales. We don't want to be burdened with manual data entry and things that, for lack of a better word, are just not a great use of time at all. I mean, it's almost useless time for us, and it gets the job done, but the onus falls on us as engineers. More often than not, we carry that burden. So we want to
yeah.
look for ways as from a cultural standpoint using these tools to get over that.
Robbie, you went to engineering school, I believe. Is that right?
Absolutely.
Yeah. And did you go to, did you have a class in which they said, well, this is how you export BOM data from SolidWorks and then type it into Excel and then email it or enter it into an ERP system and do that 10 times a week? Did you have that class? Or did they not teach you that in engineering class?
The closest thing people teach you in engineering is to use, MATLab for something like that. Create some code and try to automate it. That's probably all that the BSMEs of the world learned about. It was mostly machine design, thermo, fluids, right? Things that don't apply to what we actually do in our jobs in
Right. What about
our
the
day to
class?
day for 80%.
What about the class where they told you all the skills about, well, when you start a new project, the first thing that you need to do is rummage around your network, thinking about the last job that you did that was close enough. And if you happen to find it, and then there might be some special steps to save as or pack and go. And then you can start not from scratch and then hope that you've manipulated that data set to be just right for your new project. Did they teach you that as well, or is that not really engineering?
Oh, on top of it, they also, don't tell you, when you come in and you create a project and it's pretty close to what you actually did last time, well, now you get lazy, right? Because engineers, we're trying to save time. We're trying to get this thing out the door as fast as possible because we're trying to be efficient. And, you leave some little detail in there that you forgot doesn't apply to the project that you're actually trying to sell. So you guys can sort of understand the shortcuts, the errors, the risks that you take when you try to do these workarounds. But I'm hopefully telling stories that everyone can relate to.
Yeah. So that maybe a question for everyone else to ask themselves is, when you look at where you spend the time during your day, like how much of that is actually design or engineering or value add, something that's moving the business forward, something that's moving your own work life or career forward, or is it just a bunch of random busy work that maybe we should reconsider how that gets done? So let's move on a bit and dive in maybe another level deeper and talk about, well, we now kind of collectively acknowledge what our current work life is like. What are the tools we have available to us that we tend to use to make that go better?
Yeah, so we've got time-saving tools in SolidWorks, right? But these are what I would say are not automation tools. These are just quality of life tools that we have that helps us get the job done. SolidWorks has a ton of time-saving tools. That's why most of you guys invested in this as a solution. Sheet metal weldments, they automate a lot of the things like bend deductions and making sure you have gauge tables and doing the prints, right? So that you can get a flat pattern, right? A lot of this stuff is automated. That's why you moved from 2D to 3D to do sheet metal. Weldments, there's a library of all the different weldment profiles, and it creates the frames and a lot of things like cut lists for you automatically. There's configurations in a model, in an assembly, even within your drawings that help you do things that are the same but different. We've got pack and go in that same realm. Some companies aren't allowed to do configurations because their ERP doesn't play nicely with it. So for that, we have pack and go, which allows you to kind of copy a project as is, put it into a different folder, cut it up, and then recreate it into another project. Of course, if you have a master model of your product and you're doing a lot of the same but different, you probably have put equations or calculations into the model to help drive some of that functionality. So you're already starting to take the approach of, well, I'm going to use the tool to see if I can find shortcuts and ways to do things. And then going even deeper into it, if you are kicking items over to ERP, you are trying to automate a lot of the things in your drawing so you don't have to keep typing in the same things into your title block. We've got custom properties and the custom property tab builder to help us automate and make a lot of that stuff consistent. You know, what is it made of? How much does it weigh? What series is it? What color is it? These are all custom properties that we can add, you know, to a part that can exist in a drawing and help us be more consistent. And from there, you can get even deeper, right? We've got the ability to play with drawings and make them consistent, you know, with a template. And then we have macros that we can run. You know, SolidWorks has an open API. And then on the highest end of this, you have macros that you can run that will do some of these batch jobs, like automatically creating PDFs of all your drawings at the end, or generating an Excel file that needs to look a specific way. So these tools are built into SolidWorks, but it's not quite design automation. These are just time-saving tools. So hopefully you guys are taking use of all of these, as you do own them already, and the cost of these is built in. It's included with SolidWorks.
And so, yeah, so we kind of characterize all that as time-saving and maybe organizational in nature, right? It kind of forms this like comprehensive wrapper around the engineering, designing exercise, and it all works great. We're not here to poo-poo any of these tools. There's a time and a place for all of them. But maybe we've seen scenarios where a tool can be perhaps used improperly or used to do something that really wasn't intended to do. Kind of the big one that we see a lot is configurations, right? So much like trying to drive a screw in with a hammer, right? To use configurations we see all the time end up being overused to the extent that, you know, assemblies become unbelievably huge, impossible to open. The nature of how different aspects of the configurability of the product is packed into configurations can get pretty unwieldy, right? And if that feels like something that you experience in your day, that configurations now turn into this more of like something you worry about more than something that you feel like is helping, then that's like one example clue, like, all right, it's time for a better tool. So I don't have any other examples like that come to mind, but that's something that we see quite a bit, so.
Mm-hmm.
All right, so we have the product that we're going to go through an example and demo DriveWorks is this gantry crane, right, for a hypothetical material conveyance company, right? So maybe we could just spend a few minutes talking about how is this a configurable product? How would we traditionally handle this thing in DriveWorks, or excuse me, with SolidWorks, like in our normal sort of design environment? I don't know, just things that come off the top of my head. Like we have the notion of, well, what's its capacity? So from a structural standpoint, what can this thing endure? There's like dimensional aspects like width and height. So we can imagine how we might use various forms of configurations. We might have a library of files that are suitable for various like working load thresholds. We might have a suite of drawing files that are available to handle any number of scenarios. Any other thoughts like that come to mind, Robbie, of how you would kind of look at that product and apply SolidWorks to it?
Yeah, different heights, different spans, different loads, different beam thicknesses, etc. Yeah, SolidWorks is built to handle something like this. But
yep.
At the end of the day, you still have to manually go in and drive that design intelligence and tell it what to do. And if you do that improperly, you're going to end up with the improper result.
That's right. That's an important phrase to keep in mind, is design intelligence or design intent. That has to live somewhere. Right? It's either going to live in an employee's head, in a binder, in the ether around the office. Maybe your boss knows some of the answers. Perhaps some of it is packed away into a SolidWorks equation that's like 3 assemblies deep in the math and the top level assembly. I mean, this design intent can really live anywhere. And so while the SolidWorks tools are good, they do invite the ability to have this true valuable design intent live in a variety of places, right? So to answer one particular technical question about a shipped product, where do you go to find that, right? I mean, who knows which equation to find where that can answer some question about what was built, right? So that's something to keep in mind along the way. So anyways, moving on from SolidWorks, it's time to introduce DriveWorks into the mix. What DriveWorks adds to this conversation is it switches us from just thinking about time-saving widgety tools to the notion of what we call design automation, right? So time-saving versus automation, we can now start to bridge that gap, okay? What is design automation? In essence, it's the ability to capture the specification of a product. It's usually done via a form, right? There's a form, a piece of UI that somebody has to enter values into. Customer name, the working load, the length and the width, for example, of that crane would be specifications of the product. So that's got to be entered somewhere, captured. Then what? Then we take that information and we apply logic. Rules, formulas, policies, know-how, design intent collectively, right? We have to process the input information against that. Then what? We end up with the result. The result is the automated outcome. We're going to see that when we get started with DriveWorks, that is your kind of run-of-the-mill SolidWorks files, drawings, assemblies, parts. When we get to the other end of the DriveWorks capability set, we're talking about integrations with other business systems, sending a bomb to ERP, emailing your coworker. Results can mean a lot of things, but when we start off with design automation, we're really just talking about your traditional set of SolidWorks files. Okay, so how does DriveWorks get us from, well, how do we start? Where might we end? This is a very simple graphic that shows that. The DriveWorks is available in 3 tiers of offering. Those are called Express, Solo, and Pro. Okay, a whole lot of information available on the DriveWorks site that will give you a full itemization of how these products compare, but we are going to give you kind of a high-level overview of that today. So let's start simple. Robbie, we're gonna go from what do I do today fully using SolidWorks methods? What's like one click beyond that using the first tool in DriveWorks, which is called Express. The good news is that everyone who's here, if you are a SolidWorks user, you have SolidWorks available to you, you already have Express. And it's easy. All you got to do is activate it. It's an Express product in SolidWorks. It's about a 30-second exercise to what I'm about to show you to get that available on your own machine. In short, what you do, you pick an existing kind of starting point, like an existing assembly, nothing too complicated. What I'm about to show you might be a good starting point. You tell DriveWorks what about that design is configurable, and then press go, right? And then just like that, you've got automation literally within minutes. So we'll kind of take a departure from the presentation here and go to SolidWorks to check this out. Okay, so here's that same product. I'm in SolidWorks. And we've got an assembly with 3 components in it, right? For the sake of demonstration, this is just a very simple use case, right? So we have a normal SolidWorks environment, and then off to the right, we have the DriveWorks Express pane, which is enabled when you activate your Express product, okay? So what I'm about to describe as capturing applies to any tier of SolidWorks product. Capturing is the idea that you have something in SolidWorks that you need DriveWorks to know about, such that when you enter a form and press a go button, DriveWorks can then go back to SolidWorks and put in your new values, okay? So for example, we have the leg, okay? Within the leg, we have captured a few items, a few configurable elements of this thing in DriveWorks, okay? One is this little support structure, right? So this is a feature in SolidWorks. Any old feature you can capture just like this. And just fast forwarding a bit, what is configurable about this feature is it's either there or not, right? So in modeling terms, it's either going to be suppressed or unsuppressed, just to keep it simple. Furthermore, we're going to capture a few dimensions like height. And then it's important, probably from an engineering perspective, right, that there's some minimal overlap between the top and the bottom sections of this leg, right? So a little bit of engineering insight is going to get pushed into the mix as well. Furthermore, we're going to capture some custom properties. Why not? And we have the ability to capture configurations within the model And if this model has an associated drawing, which it does, the leg part has its own dedicated drawing file, we're going to make sure that DriveWorks is aware of that as well. Okay. We can look at the universal beam, the beam that goes across the top, same sort of thing. It's got configurations, the width, the I-beam profile, things like that are going to be configurable along the way. So that's capturing in a nutshell. Again, telling DriveWorks, hey, these are all the things that we need to account for in the SolidWorks model. Done. Pretty easy. Next step from there is to build some kind of interface, right? A form is the simple way to put it. The form builder in Express is real easy to use. You can see here we've got a number of pieces of information that we're going to capture. Okay, if we want to see what that might look like, there's a little test button, and here it is. Nothing special, just kind of a top-down series of questions for the user, right? And so we're going to ask for the project number, who drew it, what's your working load, and then some dimensional stuff. Now you see we have drop-down menus. We have a spin button that we can interact with, and then a separate field that we could literally type values into if we needed to. Okay, so in Express, even you do have some varied functionality for forms. All right, let's get into all that design intent. How does that actually work? So this is the full assembly structure captured and re-represented to us through the eyes of DriveWorks. Okay, so every item here is a separate opportunity to impart some kind of logic, right? So the file name for the assembly, upon being generated, what name will that be given? Well, here's the rule builder. Type in whatever you want. In this case, the intention is to simply title it per the project number that the user will enter in the form. Okay, we're going to do some properties, right? There's one property called drawn by, fulfilled by the drawn by drop-down menu in the form. We want to do something a little bit more sophisticated. Here's some syntax, and you'll note, Robbie, this looks a lot like Excel, right? So we find that if you can write a rudimentary formula in Excel, introducing logic into DriveWorks is going to feel very familiar. So, we're concatenating some stuff. This is a static piece of text. That'll come from the form, substitute upper. This comes from the form, and that result is preview for us right here. So we're going to get something like that driven into that one particular property, right? So we can see there's more of that to come. We're not going to look at all the rules. Here's one, the dimension of the beam, right? Well, depends on if the user chose 500, we're going to make it, that particular dimension will be 200, if not 250, right? It's simple, but it works. It captures design intent. It gives it a home. And furthermore, it's putting us in a position to just automate all that, okay? So these are all the rules that are in place, right? Now, let's actually see this work, okay? So I'm just going to give this an example project number, TPM is the customer. Oh, I added myself to the list. Isn't that nice? I pick some values. If I try to give a width of 20,000, oh, see how it's not happy? I get a little warning, right? It must be between 1,500 and 4,000. Fine, 4,000, right? So we even get to build into this data validation, right? So if during our current work life, we're worried about fat fingering, we kind of just glaze over something, right? We can use form validation to really catch all that before it has any kind of an impact on the business or the customer. All right, so that's it. I'm done specifying the product. We've already looked at the underlying logic that's going to be processed. Now it's time to actually do the automation. We're going to click the create button and watch it go. So quicker than I think even the most veteran SolidWorks user could do it themselves with the mouse. DriveWorks is going to come in, touch every single captured part, every single assembly, and all associated drawings, and produce it within not even minutes, but seconds. Before I'm even done describing what is happening here, it will be done. So we can see the activity in the SolidWorks screen, but we also see a full-blown rundown of every step that DriveWorks is taking along the way here, kind of a log, like an activity log of sorts. In fact, we can see that there was an error somewhere along the way. So this is a little value add to DriveWorks saying, hey, user, this may not have gone as you expected it. There was something that you should go check out. And so it's nice to be able to see that kind of in process. So here it is, our fully automated results of that same product. This is same but difference from what we do day in and day out at the old crane company.
So with this free tool, you can handle the stuff on the lower end of that spectrum, the catalog and lightly to even some cases moderately configurable part of the spectrum, right? You just got to put design intelligence onto the stuff that isn't super value add. You open this master model, you run DriveWorks to create a specification, and then you're done. You let it write through the drawings and whatnot. Even if this is only, 5 to 10% of your day, at least you get it back with just a few clicks.
That's right. And so here we go. We're looking at the drawings for that one part, drawing for the assembly. So yeah. So really the work effort to introduce something like this into Express from start to finish, I mean, it might be an hour if you've never done it before. If you've done it before, it might be literally 10 minutes, so how much time did I just save myself times how many times per week? I think there might actually be an ROI there. And except that I didn't pay anything for it. So yeah, the math might not, I think the implication here is that it seems pretty obvious to at least give Express a try, right? Just give it a whirl, okay? All right, switching gears. So that is Express in a nutshell. Here we go with Solo, okay? Next step up. Now this is a paid product. However, there is a free trial that's available for 30 days. What do we get out of Solo that we don't in Express? Well, let's take a look. Okay, so Solo is again enjoyed primarily through the SolidWorks interface, okay? But it exists in a bit more of a formal basis. And there's some additional capabilities that are enabled due to the sophistication behind the scenes. So in addition to that mobile gantry that we saw, we're going to add a little complexity to the mix and say, well, hold on, depending on the use case, we might need to pivot from that simple kind of stood up crane to something that's fully supported, mounted to the floor, and is like this legitimate piece of equipment in the factory. So we now need to be able for the system to decide, do I need option A or option B? And those options are very different, okay? So the active capturing, introducing everything to SolidWorks is pretty much the same, but what is quite noticeably different is that Solo exists as its own standalone application to which we can start to do a bit more all around. So here's the essence of the same form, but it's completely custom, right? In look and feel and functionality, like every aspect of the user experience is going to be improved. Furthermore, we can add what are known as variables, right? This is little chunks of functionality that you might need in multiple places in your implementation, like this thing called a job number, or quote number rather. There's some syntax that decides what that's going to be, but we've now stashed that as a thing within DriveWorks, and now this job number we can send to the drawing or to 15 drawings. We can insert it into a property. We can distribute that one piece of information in multiple places in a very robust and programmatic way.
And what that allows us to do now, right, Joel, is okay, we don't have to touch CAD to create these models anymore, right? This isn't CAD. DriveWorks is not CAD. So if you have this system set up, you can run through this form. Anybody, sales, marketing, an intern, anybody can run through this form, and through all of the rules and intelligence the engineering folks have put into this, you can now generate data and models and drawings ready for manufacturing.
Right. Speaking of intelligence, in general, we can start to introduce a whole lot of data to the system. So I don't know exactly how, but this table is used to calculate various aspects of the beam, right? A whole bunch of engineering stuff. Frankly, I don't need to know what it is. I just need to know that it's here and how to access it. So, you can imagine doing a lookup to go cherry pick various pieces of data from this table that will somehow, some way through logical processing get driven into the SolidWorks output. Okay. It doesn't have to be that complicated. We have a list of customers. We have a list of warranty information and the cost of the warranties, just stuff, right? We're starting to gather more and more information and pack it into a more useful environment. Okay. Furthermore, we have documents like cover letters, quotes, bills of materials. We can generate those now on the fly as well. Okay. And additionally, the next most obvious thing is the space in which we create the rules. As opposed to doing that directly in SolidWorks before, we can now do something like this, where we take all of our dimension rules for something to do with a beam, right? Here we go. Just like that, we can collect and present to ourselves every piece of information routing that will go from DriveWorks to SolidWorks and look at it and consider it all together. Some of this stuff is simple, like it's just a number. Some of the stuff is based on a variable. That variable has some logic, and that logic has some logic, right? So we can really get pretty sophisticated with Solo and get a whole lot done. Okay. Now, that being said, when you've built out your implementation in this application, it is consumed from within SolidWorks. So we are still talking about an engineering tool, right? Because in order to take advantage of this, you have to be in SolidWorks to begin with. But let's see. Here we go. So I can pick myself. I'm an all-star, sure. Jeremy, great. Next, I can use a slider here. I'll put in an extended thing. I want to make sure I use that option B that I referred to. No extras, and I'll take 2 of them, right? Great. Here's a programmatic rundown, a little textual summary of what I just chose, and a rundown of my pricing, right? Here's my total price. Here's how it all added up. This is all programmatically due to what I entered into the form. Yeah, pretty handy stuff, okay? And then once I'm ready to go, click a button. DriveWorks is going to ask me, well, what do you want out of this result? Yes, I want all the files. Please make the documents for me, so on and so forth. And again, the automation kicks in. That third step of design automation is going to happen right here in front of us. Okay, as we can see, we're not using that kind of stand mount crane. The DriveWorks knows because of the length and the capacity and everything else I chose, we need a heavier duty option. So it's going to activate an entirely different assembly for us right away.
So as long as we have a general scope of predictability for the model and we have our specifications, min and max, as long as this model can exist in reality between any of those specifications, it'll simply run that. And that keeps our drawings predictable, keeps our assemblies predictable. And we don't have to put all the engineering effort into creating that one-off that you'll probably build it once, but never again. But it also gives you price, which I think is huge, because if you just need a number to send back to somebody, you need to send prints for submittal. This gets you there pretty quickly without a whole lot of work on the front end for an engineer.
Right. And for those who are paying close attention, we're doing some more advanced things with SolidWorks as well in Solo. We're adjusting drawing view sizes, repositioning them, rearranging balloons, inserting data into title blocks. There's a whole lot going on there. So here's my resultant data set. I've got a BOM, cover letter, quote. My SolidWorks files are in one happy place. And by the way, all this data is landing in the place of my choosing, right? It's ending up in this folder structure because that's where it was told to go, right? So really helpful stuff. You know, I don't know how long that would have taken someone to do manually to achieve the exact same outcome, but I imagine it would be on the order of hours, not a minute or two, right? So that's Solo in a nutshell. Pretty big gains there. And frankly, it's not free, but for approximately the seat of SolidWorks standard, you can get your hands on a good amount of capability there. Okay. Now, last step along the way here in the journey is what I would just refer to as going enterprise. What does that mean? That we're going to talk about how you would expand your user base, right? So far, these tools have been engineering minded and engineering accessed. We can talk about having salespeople access the same system, or even your end customers. Why couldn't they enjoy the same logic? You've got this form set up, look pretty easy to use. Why does an engineer have to do it? Let someone else do it. We're also talking about integrating into the business systems and handling very complex automation scenarios. You talked about custom, Robbie, on the far end of that spectrum. Well, that is handling custom products is quite possible with DriveWorks Pro. So we're not going to get into the nitty-gritty details of how that is all handled in Pro, but what you'll see here is in the Pro application, whereas in Solo, we only had a couple of places here to do things. The number of places to go and impart logic and impart functionality has like tripled, right? So just a big jump up in overall capability we can conceive there. But probably the best way to showcase how Pro can be next level and be enterprise grade is to show it in all its glory. Okay, so what I'm doing here is I'm going to window together a one of the Pro modules called Autopilot. Okay, I'm going to clear that log. We have SolidWorks sitting here. Oh, I need to activate it. 1 second. Turn on Pro, turn off Solo. I might have to restart here as well. Yeah. Give me a minute. I'm going to have you do something, Robbie, while SolidWorks restarts for me as I switch over.
Okay.
If you could go to a website that I've set up, because why not access all this online, right? If we want a salesperson to get themselves a price, get themselves their quote drawing, they might not be in the building, right? They might be at a distributor across the world, right? Or maybe this is a retail site where literally anyone on the planet is free to get a price and get some kind of result. So I set up a demo site here just for the webinar. If you have this, it's called DriveWorks Demo, tpmautomation.com. We supplied an example user and login here, but if you were to log in, what you're going to see here is, in this case, this again is showing enterprise grade. By now, our company has grown. We've added all these different products. We're not just about lifting cranes anymore. We've expanded, right? We want to incorporate more and more into our enterprise implementation. But if you could go into lifting equipment, create a design, hit next, next until you're done, and then you'll see a release button. If you could do that, I will make sure that we're ready on our server side, and we'll see what happens here.
All right. I just released it on my end, actually.
I just hit the stop button on autopilot. I may have been an untimely thing here. So here we are on a machine in the cloud, by the way. This is all happening on Azure. This is not even on my own machine. We have a seat of SolidWorks, seat of DriveWorks, and no hands touching. And Robbie, who's probably a couple hundred miles away from me right now, just did something, right? Did a thing. DriveWorks knows about it. Off goes the automation. And I don't even need to be here. I could simply not have known anything about this, close this up, walk away. It's almost lunchtime. I'll go get lunch, right? And it's all taken care of. So that's that far end of design automation, is when it's lights out, fully controlled. Every single aspect of the drawing is taken care of. Every detail of the model is in place. And oh, by the way, wouldn't it be nice if you got an email saying, hey, Robbie, your design is done, and the attached is a PDF drawing, right?
And on my end, I see the cover letter, the quote, and I see some of the lifting equipment. But after I, as the customer, if I send this off, this machine on your end is sitting on the corner, just kind of doing its thing. It's just sitting there waiting for work, saying, yeah, please feed me. And I am waiting for it to finish. When it finishes, it can send me back the stuff that I need, but it can send you in manufacturing the drawings and PDFs and all of the executables it needs to actually make the thing. So we can have this sitting out there. You can have a company intranet, or you could put this out on the internet and have your customers get direct access to it. It skips sales and it skips engineering. It goes over those two really laborious steps that most of us take, and it allows them to just get their output.
Right. So if this crane company is used to winning, let's say, keep it positive, winning 20% of the quotes and services, that 80% that they do not win costs literally nothing in terms of an engineer's time, right? I mean, they can expand, they can run a Google Ads campaign across the planet saying, hey, sale on cranes, come and get it. And that will impact the business like zero, right?
And maybe I don't like the price that I get back, right? Maybe if I don't like the price, it allows me to say, "Ooh, okay, that's a little too expensive, so let me reconfigure it there." So all that back and forth that you usually have, it's done. So you're not waiting forever on a price for them to just say they walk away. So it kind of puts the onus on them to say, "All right, here is the price. It either fits in your budget or it doesn't," and you let them do that.
Yeah. And by the way, as a user, so if you had your own account, you would see your own history of quotes, right? And all that data that you have access to is right here, right? I can see my cover letter right from the website. I can see the quotes right here. I'm kind of done. I'm ready to do business, right? The BOM, if you care to send that to the customer, that's available as well, right? So it's all about putting the right data in the right hands at the right time and doing that with consuming the least amount of in-house resources along the way, thereby reducing errors, allowing people to focus on true value add activities, and otherwise enabling the business to scale. So anyways, kind of circling back, it's not all about Pro, and we're not here to say, isn't Pro fantastic, even though it is. We're really here to just kind of discuss the totality of options available to you, starting with SolidWorks. How do you go a click past SolidWorks to Express? If you like what you see there's an option to go to Solo, right? That is free to try. Then it's really not that expensive to get. And then if you find that you're really using Solo well and you want to do more, you can migrate to Pro. That's a couple-minute exercise. So there's really a nice pathway for folks to try it out, see what it's like, and grow with it if they end up doing that. So I don't know, if we had a message to everyone that's listening here today, it would be to give Express a try. Okay, it literally takes 2 minutes to get that product activated, a couple more minutes to get your first product set up, and see what you think. Right? You might like it, you might not, but it doesn't hurt to try. If you are interested in Solo or Pro, please be in touch with us or your rep. We can certainly get all sorts of information for you, pricing, help you decide if there's a particular product that's best for your needs. And if you think that enterprise grade with the Pro offering is where you might end up, that does require a bit of discussion, right? There's a lot to talk about there. We certainly offer meetings to talk about that. Again, no charge, risk-free. We are here to help. So, Robbie, any other parting comments?
No, I would just say use the crawl, walk, run approach. This thing can go as far as you want it or need it to, really. As we get into the higher end of this, it's not a matter of can we automate it, it's should we, right? It's what technique do we use and whatnot. And when you get on the higher end of this, we have a full team of consultants that do this day in and day out. Joel's team is busy every week, every day. Tons of customers are going this route. I would say, this is really the new big thing for everyone, is trying to do more with less, and this product lets you do that.
All right. Thanks, Robbie. Good way to wrap this up. Thanks for the conversation today. I hope everyone that was listening got something out of it. We went a little over, but hopefully it was helpful. Again, be in touch if we can answer any questions, and otherwise go off and save some time.
Absolutely. And this recording will be it'll be available later next week as we let this render out. So if you guys want to revisit this or share this information with anyone else, it's going to be live next week on our YouTube channel. So you guys will get a link to that as participants. So thank you for coming out today, guys.